In this video, we'll look at a couple more examples involving these parabolas with using interval notation for domain and range and whether or not the graph represents a function. So in number 6, we have this green graph that is a parabola that opens downward. For our domain, we have to understand that this graph right here continues to go on. So I'm going to show arrows for that. And so to understand what this graph is doing, these arrows, they are pointing downwards, but think about as you trace this parabola, you're not just tracing straight down, you're also curving out to the left. So this part of the graph is moving left and down. And as we trace in the other direction, we're not just going down, but we're also moving toward the right. So this part of the graph is moving towards the right and downward. So for our domain, remember our domain is our x values. So this graph follows the x-axis and the y-axis. But for our domain, we want to know how far do we follow the x-axis. Well, the answer to that is our x values goes left and right. And we're not talking about where we're touching the x-axis. So I know there's a dot here that we touch and a dot here, but that's not the furthest left point. The graph kept going afterwards. So how far does this graph go to the left? And the answer is forever. This arrow indicates that we keep on going. We will never stop. And so we keep going forever. And how far do we go to the right? Same idea. We keep on going forever. So this idea of never stopping, continuing on, that's where the value of infinity comes into play. And we have two types of infinity. We have positive infinity for positive numbers, and we have negative infinity for negative numbers. So for our domain, it's going to use all x values, all the negative x values and all the positive x values. So our domain, we're just going to state goes from negative infinity to positive infinity. And that infinity symbol is kind of like a sideways 8. But this just means the graph keeps going in both directions on the x-axis. It moves to the left and to the right and never stops. But infinity is not actually a number we can equal. So instead of using brackets, we are going to use parentheses. So in interval notation, brackets are for numbers we can equal, parentheses are numbers that we cannot. Okay. Now, same idea for range. Follow the y-axis, which is vertical. So how far down? What's the lowest downward we ever go? And what's the highest you ever go? Well, for downward motion, remember we have these arrows that indicate we continue to go down forever. So our range, the lowest y value we ever get to, we never stop going down. So the lowest y value is negative infinity, the lowest you can go. But the highest y value, remember this green graph is what we're discussing. It does go down forever, but it doesn't go up forever. There is a highest point on this parabola, and that is up here at the point 1, 4. And remember, we're talking about y values with our range. So out of this ordered pair, we want the y value of 4 as our highest point on the graph. So this range tells me that we have a low y value of negative infinity, so the graph goes down forever, but it stops going up at a y value of 4. And since negative infinity we cannot equal, use parentheses there, but 4 we can equal, so we'll use a bracket here. With the way this graph is drawn, you can try to draw a vertical line somewhere, anywhere, but what you're going to end up noticing is as you start drawing vertical lines, such as this one, it only touches the graph in one location, so that is no issue. You can try another vertical line over here, for example, but this only touches our green graph in one location. And you can keep trying, but what you're going to find out is there's no place on this graph that a vertical line will touch it twice. So as far as being a function, this is yes. And the reason being that we pass the vertical line test, which we can abbreviate with VLT. So general idea, if you pass the vertical line test, we do have a function. If we fail the vertical line test, we do not have a function.